and the dish is actually about 30 meters away from my shack, and the Pluto is being run.
So, schönen guten Abend. So, wir sind live auf Sendung, 1 Minute nach der Zeit. Ich denke mal, das ist noch tolerabel. Welcome everybody to our live stream session about amateur radio, about satellite communications, about satellite operations. I'm very happy to be here and to be hosted by this year's remote chaos experience, which is the hacker convention of the chaos chaos computer club. And as everybody knows, due to the global circumstances, the entire event has been virtualized. And so we're trying to get together over the internet and yeah, have a great time over the next 3 days. So I would like to introduce myself. My name is Patrick, and I will be your host for tonight. And I will be supported by Niklas, who is sitting right next to me here, who is operating a little bit in the background. And yeah, so hopefully we will get all the equipment up and running. So bear with me if there is some hiccups here and there. So this is a live show, as usually there will be some quirks here and there. But anyways, okay. I need to give you a little bit of background on the environment, on our setup here. So I will be streaming this talk to you from home, basically, as many other talks in parallel and over the past days. The people that are actually part of the Congress and are happy ticket owners, they already know that this Congress is actually hosted on within a virtual world, which was specifically set up for this event. And so this world basically exists in the internet, and you can log on if you have a ticket. All the non-ticket holders unfortunately cannot, but you're still able to follow the live stream. So all the participants, or many of the participants, are actually contributing to this artificial world by having constructed their own assembly, as it is called. And our assembly that we are hosting is called the rc3spacelink. So if you are on the Congress, feel free to pay us a visit. And Niklas is currently actually inside the room, and you can see his avatar running around. So what is our assembly? Our assembly is essentially a virtualized Radio Shack, yeah, with all the nice stuff. So we have live radios in the Radio Shack. We have a message board. We have a meeting area. So feel free to pay us a visit, and we're happy to talk and discuss with you. But let's leave this for after the live session. As I want to present to you over the next 60 minutes or so, a little bit about amateur radio, and in particular about satellite communication. So what else is there important to know? So you can communicate with us live. You can ask questions if there are any, preferably through the YouTube chat feature, which is open right now. So yeah, I can see there's already a couple of people online. Hello, everybody. Hello, Volker. Hello, Kabak, Delta Golf 0 Oscar November Hotel. Very nice. So if you have questions, you can also ask me in German, of course. Yeah, so I am German. This talk is in English. I might do another one maybe tomorrow in German as well. So it depends a little bit on the feedback. So this is actually work in progress. You know, the whole thing lives as it goes. Okay. Um, so yeah, what else is there to say regarding the environment? Yeah, our assembly is up and running. So we do have also a little board, message board there. Feel free to post comments, questions, anything you want, so that we can get in touch. You will also see my email there if you want to send me some stuff over. No problem. Okay. So much for the background information, and I would propose that we jump right into it. Give you a bit of an agenda here. So we'll talk a little bit about ham radio in general, and then about the new Qatar Oscar 100 satellite, which is in orbit now for almost 2 years, and a really nice piece of equipment. And yeah, so and this is a new satellite that many people have started to use over the past years. And I would like to present to you the way on how to use the satellite if you are a licensed ham radio operator, and also dive a little bit into the technical details of the station that I'm using. The station that I'm using, which is actually sitting right next to us on the balcony. If you look at the rc3spacelink, you can see the dish sitting outside on the grass. Looks very pretty, very eye candy. I must admit our shack is not so organized as in the virtual world. But anyway, so yeah, so I'll give you some technical details. And then finally, I would say, like in the third of the last third of the talk, I would go online on the satellite, and we'll actually perform some live operations. So if there's any ham operators in the background that would like to take part over the air through space, literally, feel free to tune in. I will publish frequencies as we go. Okay, so yeah, ham radio and chaos computing. How does it fit together? Well, I think there's lots of commonalities between the two topics. I would consider myself mainly a ham radio operator. Also, of course, computers, programming, and all that good stuff is a hobby of mine as well. That sort of goes hand in hand, you know. And yeah, I was always fascinated by these conventions, this chaos communication conventions that take place every year. Always wanted to join myself. Never really, yeah, I don't know, got around this. And this year, being a virtual event, I thought, hey, let's just join and try to contribute with some content here. Okay, yeah, so here we are. What's ham radio, amateur radio? Well, let me spend a few minutes talking about this. Basically, it's yeah, it's a long story. Short, ham radio is about using your radio and talk over the air with other people. Many people would say, what's so fancy about this in times of WhatsApp and email and so forth? Yeah, it's of course it's not the way to get to talk to each other in the most efficient way, let's say. Most of the hobby is around actually the hardware, you know, the do-it-yourself part, and really understanding the technology behind it. At least that wraps it up for me for the most part, I would say. Yeah, so I mean, talking to other people around the globe through radio or through satellite is it's really fascinating once you start doing it, I must say. It's a completely independent way of communication from the internet. So should everything shut down at some point, which is quite unlikely and hopefully never going to happen, but anyways, make sure that you have a radio amateur friend in your neighborhood and you will survive. HI. Okay, yeah, let's get into the geostationary satellite that is our main topic for tonight, the QO100, or that's how the amateur radio guys are calling it. or the SHALE-2 satellite. So for this, I will switch actually to a presentation that you can also find online, and which is prepared by AMSAT, Germany. AMSAT, the Amateur Satellite Organization, has a long heritage in building and operating satellites for the ham radio community. So it goes back decades, and they've started, I think, in the 60s or so with their first satellites. And 99% of all the satellites that have ever been launched and operated are low Earth orbit satellites. And if you know a little bit about orbital mechanics, and if you may have seen the International Space Station fly by at some point, you know that LEO satellites, as we call them, have an inherent disadvantage, as they only appear in the sky for a very short period of time, about between 10 and 15 minutes or so. Now, for a long time, there was this dream of having a geostationary satellite available for the amateur radio community, because obviously a geostationary satellite has a very big advantage, as it is stationary in the sky, yeah, and always available basically, and you would not need to have antennas to follow the satellite, so the operations would be a hell of a lot easier. And about 2 years ago, the very first geostationary satellite hosting a radio amateur payload was launched, actually by SpaceX rocket Falcon 9. Yeah, and it's since spring of 2019, it's available for the community. Now, I will use this presentation to dive into the topic. It's quite a long one. I will skip through many of the slides and just concentrate on some essential ones. So you can see here some of the orbits almost to scale, I would say. Yeah, so low Earth orbit satellites around 300 to 400 kilometers above the Earth. And you see here the geostationary ones, yeah, 36,000 kilometers in the equatorial plane, and with their orbital period of exactly 24 hours, so they will always follow the Earth rotation. And there are some other special high ecliptic ones, which have different properties as well. Highly eccentric ones, yeah, I should say. Okay. So let me go through a little bit. So if you are interested, feel free to go to the AMSAT website and read up on this yourself. So pulling off such a project, of course, requires an enormous amount of organization, budget, of course. So you have to understand the satellite is not a dedicated amateur satellite. The satellite itself is actually a TV satellite, and the transponder, the amateur radio transponder, is part of the payload. So the folks in Qatar who have built the satellite were so kind to host also a payload for the amateur radio community. So let me go through this a little bit. Some close-ups of the satellite. It was actually built by Mitsubishi Electric. Yeah, so liftoff 15th of November in 2018. And obviously the booster was able to land intact. So where is Oscar 100? So you can see here, it's actually its field of view, and presented in this picture here. It's over the equator, obviously, and pretty much over Central Africa. And when you look at the footprint of the satellite, it does cover half of the planet. Yeah? And this makes it absolutely fascinating, because using this satellite as a relay, yeah, you can talk to half of the planet, essentially, from Iceland to Antarctica, from Brazil to to China. Yeah? And I've been using it now for about a year myself, and I've made many talks, and I've talked to a lot of people around the globe, pretty much. Yeah. Yeah, of course, the other half of the planet is not covered. Yeah, so our US friends, for instance, they are envy us quite a lot that we have such nice piece of equipment, and I think there is a lot of activity going on to also get one for themselves. Let's see what they come up with. Okay, yeah. One distance record, so the longest distance ever reached across the satellite from Brazil to China here, 16,000 kilometers, quite impressive. Of course, this is just the land distance. The signal goes into space and back, so over 80,000 kilometers, of course. Yeah, some statistics. So here also the geometry, the beam width of the downlink with some distances. Okay, let me go through here a little bit quicker. So some instructions on how to actually orient your receiving antenna and your transmitting antenna. We'll come to this in a minute. I will talk you through in detail on how such a station will look like. Okay, yeah, so this essentially outlines the architecture of the onboard payload. And you can see, I will not go too much into detail. You can see here a lot of switches, a traveling wave tube, and the narrow and wideband parts of the downlink chain. Here you can see the band plan. So you have to understand that there is actually two different transponders. Maybe for the folks who are not so much into this, the satellites is featuring a linear transponder, which is basically transverting an incoming frequency into an outcoming frequency. So all it does is basically relaying back the transmissions that it receives, and this is done over a broad bandwidth, basically, which means that you can use it with many people in parallel. So in a few moments, there will be the narrowband band plan somewhere. Let me just click through a little bit quicker. Oh, here we go. So you can see here the narrowband transponder band plan that is reserved for the amateur radio community. So you see here, it's about a 500 kilohertz bandwidth for the narrowband transponder. And if you imagine that a single voice channel only requires around 2.7 kilohertz, this means that the satellite can host dozens of voice transmissions in parallel. Excuse me. So let me just have a quick look in the chat. Okay, there's a couple of people onboarded here. I see Switzerland here. Hello. Okay, very nice. So if, by the way, if you see any problems with the chat, so if you cannot hear me or so, if you observe anything strange, please let me know so that we can fix this. Maybe I can also ask Niklas in the meantime to have a look into the live stream, to see if you can hear us and just to give some feedback. Okay. Also machen wir den Livestream mal an und gucken mal, ob das alles noch so läuft, wie wir uns das vorstellen. Okay. Okay, so, kannst du mich hören? Ja? Ja, kannst du mich hören, was ich sage? Ja? Läuft? Okay, sehr gut. Okay, alles klar. Okay, so we've got good feedback here from my assistant next to me that it appears that the live stream is working fine. Very nice. Okay, back to the band plan. As I said, this is actually instructing the user on how to use the satellite. Where are you allowed to send, and what areas are reserved for which operating modes. Yeah, you can see there's not only voice SSB here, single sideband, but also digital modes, yeah, and also the classic modes CW, which is Morse. There's also a small room for this. Okay. So what else do we have here? These red areas are also quite interesting. They are beacons, and these are reserved areas for special signals that the satellite is transmitting in order to provide some guidance, yeah, for the user, which I will show you during the live part of this session. Okay, now what do you need? What do you need to actually use the satellite? Yeah, so actually it's very easy. Yeah, so when people think about satellite communication, ground stations, and so forth, sounds really expensive, but it is not actually. One of the reasons is that the downlink is actually using a very similar band as the TV satellites are using. Yeah, so and you can use a TV receiving hardware also for this type of satellite. And this is built by the millions, you know, in very large quantities, so it's really cheap. So here, this you can see here on this chart a basic setup on how to listen into the satellite. It's not yet for transmitting. This is a different story, but we'll come to this also in a minute. So you can see here, you need just a standard satellite dish. 60 centimeter diameter is fully sufficient. I've talked to people that actually use 30 centimeters on their campgrounds somewhere, but this is really borderline. 60 centimeter or 80, I would say, is really good. Then here you have the LNB. Yeah, typical LNB. They cost a few euros only, which is actually transverting the X-band signal from 10 something gigahertz down to 700 something megahertz. And okay, here's a little circuit which is bias T to provide the LNB with power. So basically you have it's a DC block, and all you need to do is find a suitable sized coil in the capacitor, and you solder this together from spare parts. Very easy. You can buy them as well as you like. And last but not least, here you've got a software-defined radio. These little RTL dongles, the RTL sticks, they also come in really cheap, and they will basically sample the signal, the entire bandwidth actually. Yeah. So as I said, 500 kilohertz of the downlink, and those things here they are up to 1.5 megahertz or something. So you can listen to the entire band simultaneously. Yeah, so much. And with these little things here, you are very easy to set up your downlink. Now, in the end, what you do with the RTL stick, you stick it in your PC, in your computer, and you run a software which is then nicely presenting to you the spectrum. And I'll show you this in a minute. Okay, let's see. Yeah. I talked about the software. This is the software. It's also a freeware software built by the ham radio community. This one's called Sdr Console. There's other ones as well. I'm using this software as well. You can see here the spectrum waterfall diagram. Very comfortable to work with. Okay. Yeah. The band plan, okay, so what else do we got here? Yeah, so you can see some examples of people operating it from their shacks, some guidelines, the do's and don'ts. Yeah, here you see some examples. Sometimes people are a little bit, yeah, undisciplined, I would say, you know, so zigzagging across the band or here. So this happens sometimes, but I must say in general, people keep order quite nicely. Yeah, one important thing is to not overdrive the satellite. So there is a certain limit of power that you must transmit with. And this is quite important. And there are some special features, some safety features implemented in the operations to make sure that the people do not overstress it. Next to the narrowband transponder, there's also a wideband transponder, and this one can be used for digital television. I've never used it myself, so you need a bit more power, a larger dish in order to do this. So definitely interesting if you have the space available to do this. But this is something I've never done before. But there's many people doing it, and I'm sure you also find many resources if you're interested on the internet on how to set up. So that's why I will skip through these specific slides here. Yeah, the SL-SAT, so the Oscar 100 Satellite Control Center, is located in Qatar, in Doha. And from there, basically, the television services is provided for the region. It's the main mission of the satellite. But as I said, secondary payload is the transponders. Yeah. So the entire project is organized and done on, is managed by the AMSAT Germany organization. And you see some of the key folks here on the pictures. And I must say, it's really absolutely fascinating. And those folks have done an outstanding job to first organize such a complex project, you know, but also to build up all the necessary infrastructure which is necessary to ensure operations. So what you see here is actually the ground station of the AMSAT team. And this ground station, the purpose of this ground station is not just for recreational communication, but as I said earlier, the satellite beacons, for instance, are generated down here. And some of the safety feature, which I also mentioned, is also provided by this ground station hardware. We'll talk about the beacons in a minute. So AMSAT Germany headquarters in Bochum. So let me skip over some of these slides a little bit more. Okay. So we're coming to some more technical details here. So if a little bit more hardware that you need to get QRV with the satellite, as we say in the community, so to get operational. In order to translate the frequency band into a usable frequency band that you can work with, you need down converters, and there is a variety of down converters available. You can buy them, you can build them yourself. Go to the AMSAT shop. This is a starting point if you want to have a look on how much this equipment would set you back. So here, you can see an analog version. So before we had talked about software-defined radio. This is a purely analog version. Lots of those people that are in the community, they are fully equipped with say older equipment, let's say, that they're using for shortwave communication or VHF, UHF communication. And if you have the right transverter, of course, you can then translate down into the frequency bands that your equipment is capable of. So the AMSAT people are constantly improving their designs, and this looks really professional. So with a few €100 you can get this stuff here, and there's only a few things to do in order to get them up and running. Frequency stabilization. This is also quite an interesting topic, and I think we'll reserve this topic also for later. Once we are online, I will explain to you on how to actually tune your station and make the station usable. because with the stock equipment, yeah, that you buy in the shops, there are some disadvantages, and you have to do a little bit of tweaking in order to optimize it. Yeah, some antennas, some examples of antennas here. Yeah, you can see here, for instance, this is a setup with two dishes, one for the downlink. This one here, you can see here the LNB for the downlink, and this is an uplink antenna. This is one way to do it. Here is a helix antenna for uplink. It's quite a long guy. This one, for instance, here is Wi-Fi uplink antenna. Yeah, so this is also quite cheap. You can get them in your in your local hardware stores, because also I should say here, as the downlink is in the television frequencies, the uplink is in the Wi-Fi frequency, which is also a nice move, because there's lots of cheap equipment available in the Wi-Fi world, yeah, which you can make use of and modify and optimize for your individual purposes. Yeah, so some people actually transmitting from inside their house. Here's a variety of uplink antennas. So you can see here a patch antenna. This is here a helix antenna. We'll talk about the helix in particular a little bit more, because this is my preferred solution, and I put a little bit of work into this myself. Interestingly here, this is a combination of a helix uplink and a LNB downlink. Yeah, so it's a so-called dual band feed. The advantage here obviously is you only require a single satellite dish, which you use for uplink and downlink in parallel. So if you don't have a lot of space, then this is the preferred solution. That's also the solution that I'm operating here myself. Yeah, power amplifiers. Yeah, so of course, you need to boost the signal somewhat. The standard Wi-Fi that you're using inside the house for your cell phones is not sufficient. When you look at the link budget, you need about, if I remember correctly, correct me if I'm wrong, I think 400 watts EIRP to reach the satellite, and with a, let's say, 24 dB gain dish and a 3 watt output power amplifier, you are already up and running. Yeah, so, and 3 watts is not so much. And there's different solutions available. So here is some third-party hardware of 2.4 gigahertz amplifiers. I started myself with a little Wi-Fi booster, which I bought on eBay from China, set me back around 35 euros or so. And this gave me enough power to get online. There's some luxury versions here as well, you know, with some nice LEDs and things here, SWR indicator and so forth. Very nice. Yeah. And here we're coming to a very interesting piece of kit. And this is also part of my station. This is also a software-defined radio. This is actually a education kit, which is built by Analog Devices for students, for professionals to get into the field of SDR. And this one is very nicely usable also for QO100. The nice thing is it has an up and downlink, yeah, so both in parallel. So you can use this for receiving and transmitting. Actually, dual full duplex. Yeah. And this is quite cheap. This is around 120 euros or so on DigiKey. However, you need to do a little bit of tweaking in order to get this properly up and running. Yeah. Okay. Yeah. So much for the AMSAT standard presentation. Kudos to AMSAT. Good job, guys. So this is really nicely done. And yeah. So let's have a look at the time. It's 20:34 right now. We have a few more minutes until we want to actually start using the satellite. I will now switch to a different website. Just a second. So, okay, so you should see here actually my the website that I'm operating on qrz.com. Oh, I'm in the background. Just let me get me to the front here. It's not open. Here we go. Okay, yeah, I put a little bit of information on this page also about this event here. But if you scroll down, you can actually read up about how I built my station. And maybe if we have a look at the requirements that I had, yeah, I wanted to have a portable design. So I wanted to have my ground station to also be able to put in the car and drive out somewhere or to friends or conventions or whatever to operate remotely. And I also wanted to get operational quickly. I didn't want to waste too much time experimenting, which is fun, of course, and of course justifiable. But I was just keen on getting online, so I wanted to use some proven design, and that's why this also drove my design significantly. And last but not least, I wanted to have a simple design, which is a single dish, which then actually narrowed down the antenna solution to a dual feed. So here you can see the general architecture of my station. So the whole thing is boxed in a ruggedized aluminum case, and you can see here in the middle, centrally, the Pluto SDR, the software-defined radio, as I said, for both up and downlink. It's operated through Ethernet, so it's just very convenient. All you need to do is you plug it into your home local area network, and then you can operate the satellite from anywhere within the house, basically, or even remotely if you have a VPN dial-in or so. I've never done this, but there's also people doing this. So you can see here the uplink branch, the high power amplifier, and then a downlink. So here the LNB power T to supply the LNB with power, and an attenuator, because the Pluto has also some limitations in its own. So you need to be able to, you have to limit the power a little bit into the Pluto. Yeah, and then we've got some power input here, some power management. There is a 230 volt input or a 12 volt input alternatively, so you can hook it up to a car battery. Excuse me. Okay, yeah, some details on how to actually modify the Pluto. I don't want to dive too much into this. Feel free to also send me comments or emails if you want to have some further info about this. The thing is that the Pluto itself is equipped with quite a, well, let's say cheap oscillator, yeah, which is drifting with temperature. So, and which is not, say, in specification for satellite operations. So this is something that you need to modify. It's a different solution on how to do this. You can either replace it with a higher grade oscillator, or you can also feed in an external oscillator, which I done here. You can see this red cable here, basically, which is feeding in an external 10 megahertz reference. And then it also works. Yeah. So this is the box. It's actually a two-story setup. Yeah. So this is a lower, the first layer, the lower layer hosting the Pluto, the 10 megahertz reference oscillator. And then the top one, which is missing here, is the power management. Yeah. Okay. So about the antennas, this is a special topic for me because this is something that where I put a bit more effort into it. You can see here, this is a design that I did in 2019, and I built this with a few things in mind. So first, I wanted to have a 3D printable design, and something that just works. And this design is basically based on other proven designs that have already been operated by other people. I think what's new is that it's actually quite a compact design. Yeah, you can print this with your printer at home, and you have to use some copper wire here to produce a helix antenna. You have to do some matching, of course. And also what's important to understand here is that it's got a radome. It's a screw-on radome, actually. And I will show you this. Ja. Mach mal aus, bitte. Ja. I will show you this in a minute. So let me just pause for a second and check the quality of the live stream. Just want to see if there's any problems here or so. I can see we have 39 visitors in the stream. Very nice. So so the YouTube Studio still tells me that the connection is good. So I trust in this. So as I said, no, please let me know if there's any problems or so, if there is if the audio is bad or anything like this. Okay, let me just show this to you. So here you can see the design that I made basically, which is a helix dual feed. Yeah, just hold this in the camera here like this. You can see here, this is the LNB. It's got a green cap. That's why it's not really showing up here. Very interesting. So this is a standard LNB that you can buy for, I don't know, 15 to 20 euros or something. And here is the feed antenna, yeah, and this is I would say 99% 3D printed or 90% 3D printed. So I'll remove this radome to show you a bit more details. So you can see here the copper winding, so it's a 3.5 turn helix. You can see here the matching element, yeah, to match with a 50 ohm connector. And here in the back, you've got the N-type connector for your uplink. And it's really easy to install because all you have to do basically is to just stick it in here. And then you've got here on this side, you've got a little clamp screw, which will then, here's a little clamping mechanism that if you tighten the screw, which will basically hold the LNB in place. And then it's a rock solid thing here with the radome, the screw-on radome. It's pretty much watertight. So I'm operating this since over a year, and I'm occasionally opening up. There is no corrosion, nothing inside. And also, if there is rain droplets over here, I don't see any significant attenuation. Yeah. Excuse me. Yeah. So if you're interested in this design, you can actually print this yourself. It's published under a open source license. If you go to the website, you can see here a link to Thingiverse, where you can basically download where you can download all the files necessary to build this antenna yourself. For the folks that are not comfortable in building yourself, or if you don't have the right tools or so, I can always help you, and I'm also providing these antennas for sale. So just drop me a mail and we'll get together about this. Yeah, you can see a nice a variety of different builds from other people here. So it's quite widely used in the meantime. So it's quite nice things. There's some reviews here. There's some videos on my website which you can have a look at. So this was, for instance, a video by a guy that actually did quite a professional review of the design. Very nice. Some instructions on how to mount it and so forth. Yeah. Yeah. You can see here I'm quite interested in 3D printing and mechanical design. So here this is a mock-up of a rendering of a experimental design, a patch antenna, also 3D printable. I have made a test version of this as well. So if you look at this here, it has inherited quite some design features of the helix antenna, but inside it's actually a patch feed, a circular polarized 2.4 gigahertz uplink antenna. But this still needs some work and some tuning, so this is not yet released, I should say. Okay, but really nice project. Okay, yeah, I've made a variety of different antennas. For instance, you can see here a copper strip antenna. So I wanted to improve the design a bit more because you can imagine that a thick copper wire, of course, shields the downlink, and then you lose 2 to 3 decibels of downlink power with a copper strip. You reduce the shadow, of course. On the downside, it's not as doesn't have the same power rating, of course, right? Yeah. And yeah, different radomes for the 3D printing enthusiasts. So this is a different version of a cone here of a radome. By the way, due to its shape, this is called the ice cone feet. You know, that's also its brand name, let's say, under which it's known. So if you search for ice cone feet on Twitter, or so you'll get the leads. Yeah. So this is a single layer print here, almost translucent, as you can see here. You know, it's very thin, and yeah, but not as mechanically rigid as the standard. Okay. Yeah, making copper helixes is quite easy. If you look at the website, they're providing some tools. So this is also a 3D printable tool, basically a cylinder with a circular groove around it, and you can use this to wind your helixes and get perfect results with this. Excuse me. Okay. Well, I think let's wrap up. Use time for wrap up. It's 20:46, so we've got another 15 minutes on the clock. I've gave you a little bit of context of background on satellite communications and on the QO100 satellite in particular. And I showed you a little bit of detail on how to build your own station, which is definitely doable with also let's say moderate investment. Yeah, and so what's left is actually using the satellite. So let's not waste time and jump right into it. So for this, I have prepared another screen here. Okay, very good. You should be able to see this. So just a second. Okay, just send my assistant out to get a glass of water. I'm losing my voice here. Excuse me, folks. All right, so what you see here in the background is the Sdr Console Software, which is up and running, and the waterfall shows the ongoing satellite activity on the Narrowband Transponder. So to orient ourselves a little bit, what do we see here? So we've got here in the upper part the spectrum. There are some spectrum indicators here as well, which are resembling the band plan essentially. So you see here the beacon, the left beacon on this side, where I can zoom in a little bit. Yeah. Oh, many thanks. So the purpose of the beacons, I wanted to tell you a little bit about this. First and foremost, it's actually to notify where the band starts and stop. Yeah, so it basically this is the lower limit of the frequency that you're allowed to use, indicated by the beacon. Yeah, simply because it's located here. And the interesting thing now about the beacons is that actually the satellite is not producing the beacons. The beacons are produced in Bochum by AMSAT themselves. So they are actually sending up the beacons at 2.4 gigahertz. And not only this one, but 3 beacons. And all what the satellite is doing, it's relaying it back on the ground. Of course, AMSAT has very precise clocks on ground. And so you've actually got a very stable frequency indicator as well, which is important, as you can see in a moment. Second purpose of the beacon is also to provide a reference level for the transmitted power. Yeah, so you can see here. You can see here in the S meter about 39 dB, which it's a relative. If I go to the ambient here, you can see it goes down to about 10 or something like this. Yeah. So and here we've got 39. I think my station is not properly tuned, so you should be able to receive the beacons with, let's say, about 31 dBs or so above noise. And you must not exceed this power limit. Yeah, this is of utmost importance. Yeah, because if you did this for a longer period of time, this might actually degrade the payload. So that's really important to know. But luckily we have these beacons, and if you monitor your own signal and compare it with the beacons, you have a very nice reference, and you can make sure that you're not exceeding the beacons. Yeah. Okay, so this is the left beacon. Let's move to the right. On the right side, there is another beacon, the upper beacon here on this side. Not go into this. And then we've got a middle beacon, which is quite interesting. I zoom into this a little bit here. It looks like this. And this one can actually be used to stabilize your LNB. Yeah. So I have to, let me explain. So the LNBs, as I said, it's a commercial off-the-shelf product, and it's in its own not very stable. Yeah, it's sort of drifting along, yeah, from left to right. So by a few tens of kilohertz usually. If the sun shines on the LNB, it's drifting in one direction. If the next cloud comes, it's drifting the opposite direction. If you don't compensate for this, your voice goes all over the place, basically. All right. Remember, a voice channel is 2.7 kilohertz. If you offset by 40 kilohertz, you're gone, basically, right? So you need to make sure that you stabilize your LNB. And there's essentially two different ways on how to do this. First is the easiest one, and the one that I'm using also, is use the beacon. Yeah? So the beacon tells you, hey, this here is actually 10.489747 something gigahertz, and if you receive this beacon at a different frequency, you know that your LNB has a certain offset. And the software here actually has an algorithm that is detecting this offset and automatically compensating, which works perfect, I must say. Yeah? A really nice solution. I'm also a software guy. I love software solutions. It's really great. Second option on how to do this is actually to modify your LNB. Yeah? You can, similar to what we did with the Pluto, you can also feed an external oscillator into your LNB, but which you also have to synchronize with, say, GPS or so, which is, of course, a lot more effort. You have to open up this thing, you have to fiddle with a microscope and things. It's quite complicated. It's doable, let's say. And if you can also buy modified LNBs if you wish. But I must say I prefer the software solution and the beacon solution. The only, I would say, disadvantage of the beacon is that sometimes the beacon doesn't work. I mean, the beacon is almost perfect. It works most of the time, but sometimes there are some idiots, yeah, some pirates or so, that are blanking the signal, that are putting noise over the signal. So I don't know why they are doing this. Yeah, some people are crazy, and then the beacon doesn't work. Actually, two days ago when I was on the satellite the last time, I wasn't able to get a lock, and I was thinking, what the hell is going on? And I looked at the middle beacon and saw there was some guy just scratching all over the waterfall. Anyway, so okay. Yeah, so we're all anxious to actually get up and running. So let me switch this thing on. That's how the beacon sounds like. Not very interesting. Let's go to the left beacon here. Not centered, just a sec. So this is how the left beacon sounds like. Yeah. And yeah, so what else is here? Go down a little bit. You can see, of course, some communications going on here. So this is a typical SSB communication here. Let's listen in. I clean up the volume a little. Eastern European, sorry. Don't know what this is. Let's see.
Habe erst angefangen mit einer Body-Batch und da
German
war das
station.
mit der eigenen Beeinflussung ja war nicht vorhanden, aber
Let's hear a strong signal here.
Delta Golf 0, Oscar Papa Kilo, Delta Oscar 5 India Golf 5.
So, also
alles klar, Markus, ne? Ja, wie gesagt, bei mir war es ein bisschen anders. Ich bin also gleich zum Amateurfunk
Itt megvan az ember, meg eszközt, már annyit cígolunk magunkkal. Már a mobiltelefon felszívott egy csomó funkciót, úgyhogy csak egy mobiltelefon kell, meg a kis rádiót vinni. Na, egyébként láttam olyan mobiltelefont, amiben be van építve a DMR, na nem ez a szoftver.
My vector, Delta Fox 2, Whiskey Fox, Alpha Oscar 50, United Papa Charlie, please.
Nice. Okay. Let's make this down a little. Yeah. Okay, sehr gut. So you can see we've let me just have a quick look in the chat here. Okay, stream is working good. Thank you. Okay, very nice. Great. Thanks for the feedback, guys. Okay, so you can see the narrowband is getting busy a little bit. It's almost 2100, so people are chatting again after having dinner time, and yeah. So let's actually get online and do a little bit of QSOs here ourselves and talk to the satellite. Let's start the rc3 spacelink. Yeah, it's a prime mission to actually beam some messages into space and back from the remote chaos experience. And let's see who's online. Maybe we get some response. We may need to be patient a little bit. So let's see. Let's find a free spot here somewhere that we can use. So we go to the 860. 860. Okay, here we go. Actually, before I do this, let me reduce the throttle a little bit and do a little bit of testing. Testing 1 2 3. Testing 1 2 3. Okay. Yeah, I can hear him. As you can see, I can hear myself back because it's basically the round trip from ground to space and back, plus some additional latency through the SDR involved. Some people say, okay, the analog world, you know, has this advantage of less latency, but I must say, yeah, it's I don't care. So. Okay, so 90% here, very nice. So we have about, I would say, 4 watts of output power now with my setup, and yeah, over a 100 centimeter dish outside on the balcony. Let's go for it. CQ satellite. This is Delta Charlie 8, Papa Alpha Tango. CQ satellite, CQ Oscar 100, this is Delta Charlie 8, Papa Alpha Tango, with a special call from the remote chaos experience, this year's CCC hacker convention. CQ satellite, this is Delta Charlie 8, Papa Alpha Tango, calling and listening, over. Crank up the volume a little bit. So for the okay, here we go. Just open my logbook so that I can track along a little bit. Allgemeiner Anruf, hier ist Delta Charlie 8, Papa Alpha Tango, allgemeiner Anruf von Delta Charlie 8, Papa Alpha Tango, ein Special Call von der RC3, der Remote Chaos Experience, des Hacker-Kongresses, der dieses Jahr virtuell stattfindet. Allgemeiner Anruf an Oscar 100, hier ist Delta Charlie 8, Papa Alpha Tango, ruft und hört.
Ruft und hört.
Delta Golf 7, Bravo, Bravo, Papa.
Okay, very good. Delta Golf 7, Bravo, Bravo, Papa. Hier ist Delta Charlie 8, Papa Alpha Tango. Go ahead.
Alpha Tango, go ahead.
Ja, schönen guten Abend. Der Name ist Jens, Standort ist in Bremen. Ja, und Julia sagt gerade 41.
Kilo Bravo, genau, das Signal ist hier schön laut, 5 von 9, gut zu hören. Mikrofon erstmal wieder zurück. Delta Charlie 8, Papa Alpha Tango, Delta Golf 7, Bravo, Bravo, Papa.
Delta Golf 7, Bravo, Bravo, Papa, Delta Charlie 8, Papa, Alpha Tango, zurück. Ja, Jens, schönen guten Abend, danke fürs Reinkommen. Name hier ist Patrick, Papa, Alpha Tango, Romeo, India, Charlie. Das ist Papa, Alpha Tango, Romeo, India, Charlie. Der Locator hier ist Juliet November 58 Uniform Alpha, Juliet November 58 Uniform Alpha, 20 Kilometer südlich von München. Und ja, wir sind hier gerade in einem Livestream. Wir senden hier im Rahmen des diesjährigen Hacker-Kongresses des Chaos Computer Clubs Deutschland, der dieses Jahr leider nicht in Persona stattfindet, wie man sich ja vorstellen kann, sondern komplett virtuell. Und wir stellen hier quasi im Rahmen dieses Talks den Oscar 100 vor und wie man QRV wird und so weiter. Und du bist unser erstes QSO hier. Das ist ganz prima und ja, vielen Dank fürs Reinkommen und wir freuen uns auf weitere Zuhörer. Delta Golf 7, Bravo, Bravo, Papa, hier ist Delta Delta Charlie 8, Papa, Alpha, Tango. Mikrofon nochmal zurück.
Ja, Patrick. 1, 2, 3. Ja. Okay, nee, geht ganz gut. So, ich kann meine Station mal vorstellen. Die ist so ein bisschen komplett analog. Das ist ein alter Icon 910. Der stammt noch aus Zeiten, als es noch einen Ansatz Oscar 40 gab. Der Spiegel ist genauso alt. Der stand 20 Jahre hinten fast im Garten und wurde nicht benutzt. Dazu habe ich einen Abkonverter von Kuno, ungefähr 5 Watt Ausgangsleistung. Und ich habe einen LNG plus einen Amsa-Dorn-Konverter. Und das Empfangssignal splitte ich hier im Chat aber auch nochmal auf, sodass ich das Ganze mit GQX, das Passband, betrachten kann. So hatte ich dich jetzt eben auch gefunden. Und den Transceiver synchronisiere ich mit so einem kleinen Python-Skript, sodass ich mit einem kleinen Klick auf die entsprechende Frequenz da im GQX den Transceiver auch auf die richtige Frequenz stelle. Und ansonsten ist das so ein Full-Duplex-Transceiver für Satellitenmodus, mit dem man, der dann eigentlich auch ja, die ganzen Sachen synchron macht. Ne? Da kann ich auch mal einen VFO-Knopf drehen und ich bin dann, damit mache ich in der Regel dann die Frequenzfeineinstellung. Okay, Mikrofon nochmal zurück. Delta Charlie 8, Papa Alpha Tango, Delta Golf 7, Bravo, Bravo, Papa. Der aber gleich zum Radio hören gehen möchte und deswegen nicht mehr nur noch 2 Minuten da ist, sage ich mal. Patrick, nochmal Mikrofon zurück.
Ja, Roger, Jens, Delta Charlie 8 PAT zurück. Ja, nochmal ganz kurz der Report für dich, also 5.9 auch super zu verstehen, klare Modulation, bisschen schmaleres Signal als notwendig wäre, aber sonst eigentlich alles super. Ja, dann bedanke ich mich fürs QSO, Jens, ne? Und wir machen weiter mit unserem Livestream der Remote Chaos Experience und freuen uns auf weitere QSOs. Alles klar, Jens, ciao, ciao, 73, bis bald mal.
73, bis bald.
Ja, 73, dann noch viel Spaß da bei eurer Aktion und mal gucken, wen ihr dann alles kriegt. Das war's ja aus Bremen. DC8 PAT, Delta Golf 7, Bravo, Bravo, Papa, 73.
Okay. Station calling Delta Charlie 8 Papa Alpha Tango. I just realized that we need to switch channels, that we need to change QRG. We are going to the 900, to the 900 QRT.
QRT.
So. Okay. Ja, vielen Dank für den Hinweis mit dem Emergency Channel. Sorry, ich hatte den noch nicht in meinen ich mache mal gerade hier leiser. Vielen Dank für den Hinweis. Die 860 ist der Emergency Channel. Sorry, folks, wenn ich den mal kurzzeitig missbraucht habe. Mir fehlt der Marker hier im Spektrum. Deswegen haben wir jetzt die Frequenz gewechselt. Wir sind auf der 900. Okay, also jetzt nochmal ein Ruf raus zum Satelliten. CQ Satellite, Delta Charlie 8, Papa Alpha Tango. CQ Satellite, this is Delta Charlie 8, Papa Alpha Tango. now transmitting on the 900. Delta Charlie 8 Papa Alpha Tango calling satellite, calling and listening, over.
Calling and listening, over. Delta Lima 7 Sierra Echo Papa.
Okay. Delta Lima 7 Sierra Echo Papa, Delta Charlie 8 Papa Alpha Tango. Schönen guten Abend.
Tango, schönen guten Abend. DC8 Papa Alpha Tango. Delta Lima 7 Sierra Echo Papa. Schönen guten Abend auch von meiner Seite. Name hier ist Sepp. Und ich bin 40 Kilometer östlich von München. Der Locator ist Juliet November 58 Bravo. Der Rapport für dich ist 509, geht ausgezeichnet. DC8P, DL7SCP.
Ja, Roger, Sepp, schönen guten Abend. DC8PRT zurück. Name hier Patrick, Papa Alpha Tango, Romeo India Charlie. Unser Locator Juliet November 58 Uniform Alpha. Nicht weit weg von dir, 20 Kilometer südlich von München. Also ein Katzensprung. Ne? Nur kurz über den Satelliten den Umweg genommen, HI. Ja, Rapport für dich auch 5.9, super Signal, sehr gut aufzunehmen, schöne gleichmäßige Modulation, wirklich klasse. Kurze Hintergrundinfo, wir senden hier von der Remote Chaos Experience, das ist die diesjährige Hacker-Konferenz des Chaos Computer Clubs, was dieses Jahr virtuell stattfindet. Normalerweise finden sich da immer Tausende von Leuten in zahlreichen Hallen ein. Wir haben das diesmal jetzt alles übers Internet organisieren müssen. Und ja, wir funken jetzt hier im Rahmen dieser Veranstaltung und wir bringen den Leuten den Satelliten, den QO100 etwas näher und erzählen ihnen, wie Ham Radio funktioniert. Haben eine Menge Zuschauer. Freut mich sehr, dass das hier alles geklappt hat, dass ich da euch das alle präsentieren darf. Ne? Sepp, und an dich, also vielen Dank fürs Reinkommen. Und ich funke heute noch ein bisschen länger durch die Gegend. Freut mich, dass wir da kurz Kontakt hatten. Ich werde mich jetzt wieder verabschieden und mal schauen, wer sonst noch dabei ist. Ne? Delta Lima 7, Sierra Echo Papa. Hier war Delta Charlie 8 Papa Alpha Tango 73 und ciao, ciao, bis bald.
Ciao, ciao, bis bald. Alles klar, Patrick, vielen Dank fürs kurze QSO. Auch an die Zuhörer. Und ich wünsche euch allen dann einen guten Rutsch mit viel Gesundheit ins neue Jahr. Ja, vielleicht klappt es mal wieder. Man merkt schon, dass irgendwie die NF ein bisschen so ganz leicht zerstückelt ist. Das ist wohl der digitale Übertragungsweg, der nicht so flüssig funktioniert. Aber es kommt alles Q5 an. Also 73, schönen Abend. Ja, der Umweg über den Satelliten ist etwas länger, als wir auseinander sind. Ich habe Höhenkirchen gelesen und ich bin hier in Grafing bei München. Also 73 und danke fürs kurze QSO.
Ja, Roger, Sepp, alles Gute nach Grafing. Danke auch für den Hinweis, dass da die NF zwischendurch mal kleine Aussätze hat. Das kann schon sein. Ich glaube, mein Rechner ist so ein bisschen überlastet. Hier läuft auch gleichzeitig noch ein Livestream und noch ein digitales Studio und wer weiß was alles. Ich glaube, da kommen wir so langsam an unsere Grenzen, aber so, im Gesamtzusammenhang, glaube ich, läuft, ist das eine runde Sache. Also, alles klar, alles bis dann. Ciao, servus.
Ciao, servus. Ja, alles klar, viel Spaß noch.
Okay, wir machen noch mal einen kleinen Versuch und jetzt haben wir schon ein bisschen überzogen. Leute, sorry, wir sind dann bald fertig. Oh, ich höre, da kommt gerade jemand rein. Das habe ich jetzt gerade nicht verstanden, weil ich selber dazwischen gequatscht habe. Delta Charlie 8, Papa Alpha Tango, QRZ.
Tango, QRZ.
Delta Charlie 8, Papa Alpha Tango, calling Sierra November 100, Papa Sierra. Sierra Norway 100, Papa Sierra.
Okay. Sierra November 100, Papa Charlie. if I got this correctly. This is Delta Charlie 8, Papa Alpha Tango. Name here Patrick, Papa Alpha Tango, Romeo India Charlie. We are transmitting about 20 kilometers south of Munich. Your report signal around, I would say 47, signal around 47. Microphone back to you. Go ahead.
Go ahead.
Okay, public. Delta Charlie 8, Papa Alpha Tango. This is Sierra Norway 100 Papa Sierra. Santiago, Nicaragua 100 Pacific Santiago. So this is my friend Patrick. Thank you very much. Contact and the report for me 47. The report signal is 5959. My name is Technischer. I spell Charlie, Zulu Echo Sierra Lima Alpha Whiskey. Repeat. Charlie, Zulu Echo Sierra Lima Alpha Whiskey. My personal call sign Sierra Papa 9, Florida, Zanzibar, Uruguay. Sierra Papa 9, Foxtrot, Zulu United.
Weiß ich jetzt nicht. Warte mal,
My city is Gliwice City.
ich kümmere mich gleich drum. Warte mal, Niklas. Ich muss mir... Ich verstehe das nicht.
Repeat. Lima, India, Whiskey, India, Charlie Echo. Locator, Juliet Oscar 90, Hotel. Juliet, Ontario 90, Honolulu. Microphone back to you.
Ich weiß nicht. Ich muss eben das Gespräch beenden, Niklas. Ich verstehe kein Wort, was der Czeslaw da sagt, weil du die ganze Zeit dazwischen quatschst. Warte mal. Yeah, Czeslaw, nice talking to you. Name here Patrick, Papa Alpha Tango, Romeo India Charlie, Delta Charlie 8, Papa Alpha Tango back. Sorry, I have to cut you short, Czeslaw. Thanks for the information. But I have to go on with my live stream, with my presentation. But I will continue on the satellite in a few moments. Thank you very much for coming in, and have a good day, and good luck to you, and hope for a good 2021. 73s from Germany, Sierra November 100 Papa Sierra. This is Delta Charlie 8 Papa Alpha Tango.
Papa Alpha Tango.
Okay, Patrick. Delta Charlie 8 Papa Alpha Tango. This is Sierra Norway 100 Papa Sierra. Thank you very much, my friend Patrick. I look into your internet page, Geos.com, very good page, my friend Patrick. Information, my station, Sierra Norway 100 Papa Sierra, special call sign, is looking internet page, Geos.com. Thank you very much, and I short contact Patrick. 73, good luck for family and you. Happy New Year for family and you, Patrick. Goodbye, auf Wiedersehen. Delta Charlie 8, Papa Alpha Tango. This is Sierra Norway 100, Papa Sierra. Bye, Patrick.
Yeah, Roger, Sierra November 100 PS. This was Delta Charlie 8 Pat. Okay, see you. Bye-bye. Thanks again. Bye. Ciao, ciao.
Bye. Ciao, ciao.
So, Ton aus. Alles klar. Gut. Sorry, Leute, wir haben etwas überzogen. Bitte seht mir das nach. Ich hoffe, ich konnte euch ein bisschen die Satellitenkommunikation über den Oscar 100 näher bringen. Wir haben das jetzt mal live gemacht und im Übrigen, falls ihr Interesse habt, euch noch ein bisschen weiter in den Satelliten reinzuhören. Man kann das Ganze auch komplett ohne überhaupt irgendwelches Equipment machen. Das sage ich nochmal so zum Schluss. Es gibt auch sogenannte Web-SDRs, also webbasierte Software-Defined Radios. Auf der rc3spacelink Assembly findet ihr einen Link zum britischen Amateurfunk und die streamen den Oscar 100 live ins Netz. Kann man natürlich nur hören, klar, aber man kann rumspielen. Sorry, jetzt habe ich auf Deutsch umgeschaltet. Sorry, guys, just wanted to say, if you're interested in further listening into the satellite, go to rc3spacelink and go to the Radio Shack. You will then be redirected to a web SDR, which is hosted by the BATC, the British Radio Club. And there you can listen into the satellite all night long, basically RX only, obviously. And that's what I did actually for weeks before I got transmissive. And this is also quite a lot of fun. Thanks for having me, RC3 and CCC. It was great fun. Niklas, vielen Dank auch für deine Unterstützung hier auf meiner Seite. Du hast dich um die Assembly gekümmert. Und ich stehe Fragen zur Verfügung. Schickt mir eine Mail, schreibt was auf das Etherpad oder sonst wie. Gibt genug Möglichkeiten. Morgen machen wir nochmal eine Session. We are having another session tomorrow, this time in German. And I think 1400 Central European time, or is it 12 o'clock? Don't get me wrong. Well, have a look at the Etherpad. I will soon publish a new YouTube live stream with a countdown, and then we'll do the whole thing over again in German this time. Hope my presentation was okay, that the quality was sufficient for this event, and yeah, hope to see you on the satellite someday, and talk to you all later. Ciao, ciao, 73s. Boah, warte mal, jetzt musst du mir mal...